Welcome to the first devlog of my project, Scorcery Reborn. So, this is largely just going to be kind of I guess, starting off with a bit of demonstration and showing what some of the actual uh, coding looks like within the spells I have made here for this game, which, by the way, that's what it is. Scorcery Reborn is going to be a game of spells with uh, design emphasis on sandbox elements and utility beyond just, say, damage values. A lot of synergy between spells and a lot of ways you can utilize spells in interaction heavy senses, if that makes sense. So if we go ahead and launch the editor here, well, not the editor, the actual game itself, you could say, we are greeted with a main menu, a text block, which will be given I guess, settings menu purposes later on. The spell test environment, which this build right here is kind of meant for just building the actual spell system and testing and making spells themselves before getting into any of the actual long-term design philosophies. I'm going to go ahead and click here, which should bring us into the actual spell environment here. Give it a second to load though. I am not used, well, the actual engine, I've never actually run this with OBS, so some things might break. Now, you may notice a bit of a shimmer effect on the actual character here. This is just a material that I was toying around with earlier. This will be removed in future builds. So, to kind of start off, I have built 3 spells so far in my design of this game. It seems I have an invisible entity here. Hold on. I am going to have to address whatever this invisible collision is. I've not actually come across that in my entire time of actually making this. Let's see if I can damage it now. I can't. Anyway, I have 3 spells built currently. The first one is called Explosion. It does exactly what its name says. It casts an explosion. The explosion has a knockback effect and does half damage of pretty much every damageable entity that so far exists in the game. The design philosophy of this spell is meant to be used as a kind of a pseudo burst movement sort of deal, and also as a way to get started in gaining air in actual movement. In the way you can cast it can actually be changed with input. So you enter what's called the charging phase, which allows you to charge the spell, and you can cast it in different ways. So the first cast is under, there's one for behind, and soon I will be adding ones for the sides, and I'm also going to be changing it to where you can't cast it under yourself anymore because um, of changes in design philosophy. Now, if we go to one of these, which, by the way, to anybody looking at the animation of the character just sliding around, I didn't make an animation for running while running while charging because I am not exactly an animator. I'm a computer programmer. Anyway, as you can see, it does 50 damage to whatever it actually comes into damaging range with. Now, that's something I don't, I guess, take as much personal pride making. I did use a lot of like components to kind of build that. The real bread and butter of like, I guess, heavy programming on my end is the second and third spells. I call Wind Volley and Newton's First Bolt. First bolt? No, just Newton's bolt. Newton's bolt, which is a reference to Newton often being credited for gravity. Anyway, wind volley just uses air to push things. So if I go here, as you can see, these little test dummies here react to me pushing them around. Now, there is a secondary effect that anytime you push against something, there's an actual equal and opposite force. So, if I say push against the ground, it will launch me up. Or if I push against something towards the side, if I can find a good angle, it will push me sideways. Now, granted, because of the way the hitbox is, it's not launching me as far back as it would if I aimed down, because the way it works is there's a bunch of line traces, which you can't see it, but when I show a bit of, I guess, some of the coding here to kind of show some of the design philosophy in making this, um, it will become more apparent on like how the line traces, like for here, you can't see it, but only half of the line traces are actually um, pressing against anything, whereas for here should be more of them, but there's also things behind me, which means the pressure's not going to be as much. And it also builds over time and exposure. And so pushing it on the ground just means that you're using the full length of most of the line traces. I'm actually going to go ahead and restart the demo here because I didn't fully integrate the nighttime system yet, and it would be too dark to fully see. So it's fine and dandy. We have some movement. One of these things does some damage, but now we have to wonder, okay, what's some of the spell synergy I mentioned earlier? Well, that's where the third spell I've made comes in, Newton's Bolt, which um, is basically a lightning type effect attached to a it's a placeholder ball at the moment. I will be adding a Niagara effect to kind of complete a lightning type aesthetic. I'm also going to be replacing the projectile with a line trace, or what I'm probably going to do is use it as a node to have a that draws a splice behind it, which a splice in Unreal Engine just makes all it makes is just a line that can like curve and be manipulated and programmed to do things in real time. So if I go ahead and hit this test dummy with it, and you look to the top left of the game display, you may notice that it's not dealing much damage. It's dealing like 4 damage. That's because it uses a logistical growth curve to curve the damage. In other words, it changes depending on a value. Well, that value, and this is where the I guess synergy between spells comes in, it depends on how much it has dropped. In other words, if he drops from a farther distance, the maximum height, differenced with the height it's at when it collides with something, it is then plugged into a logistical growth curve to deal more damage um, with regards to 100 based on how far it has dropped total. So the synergy comes into being able to do stuff like this. You gain more height to make gaining higher damage values. That one did 89 because it was from a higher height. Uh, and it allows you to do it from closer because obviously if you're right next to the dummy here and then you just hit it point blank, while it did die, that's because it only has 100 health, and I just did 80 damage to it, plus like 4, plus 4, plus 4, and that final 4 took it over the edge. Um, because of the fact that, you know, it has to drop, you'd have to kind of wait. Well, if you use this, then pelt it hit this one right here, you can do it from closer. So if we go ahead and do this, you can also just kind of focus on getting a snipe into it. Anyway, this is all fine and dandy, but what's the, I guess, future kind of plans for this? Well, let's actually, before we get into that, let's start with the getting into some of the design I've done here so far. And we're just going to immediately jump to some C++ classes here. Um, some of these are just experiments of getting used to using C++ within Unreal Engine. So let's take a look at Wind Volley, which once C++ fully loads up, is it gonna show it on this side? Maybe, potentially. Do a thing, maybe? Alright, so we can see here, this is the .cpp file, which, if we take a look at what's going on here, we see a nested for loop and a nested if loop within, or if loop, the if nested within an if, which is inside of a nested for loop, and a if-else condition here. Now, personally, when it comes to video games, I typically prefer to use switch cases when available for performance reasons, as checking for a condition every single frame is not very performant. That said, in this particular case, it's too few conditions for that to make using a switch case a very good idea. In this case, I do believe that from a, I guess, closer to middle perspective, the if statements here are handling memory better than a switch statement would. If memory serves, if has a, I want to say, big theta of log n in performance. I wouldn't quote myself on that. I would have to do a quick Google search. Um, that said, we kind of go into the for loop and see what's going on here. Well, as you can see, we're creating an array of arrays of line traces. In other words, a matrix of line traces. The way it renders in the game is it's a square of them. So the first and second loops here are constructing these um, traces using the range of x and the line spacing, which if we go ahead and jump into Unreal real quick, and I should probably show some of these values so the code can, I guess, probably be a little more legible in that sense. Give me 1 second. Should be under content. Oh, that's environment. My apologies. We take the spells. Give it a second. I don't usually run OBS while using Unreal Engine 5, so my CPU probably is not liking what I'm doing right now. Okay. This is a spell I was experimenting with using the divots system, so it's still something I'm planning on making, but I do need to find a better method to actually do what I was planning on doing with that. So, here we go. Wind Volley. Here's the blueprint. Now, you're probably, when loading in here, you'll notice that there's probably going to be a lot of blueprint there. None of it's actually doing anything. And I can quickly show that's the case by showing that none of the actual code of the blueprint is connected to any. If it'll load here. Now, what's going on with the load here, another thing, is my SSD that I run Unreal Engine 5 on is a little full. So, as you fill up an SSD, it will lose a bit of its speed until you do kind of clear out some of that space. So while that does its thing, we're gonna, oh, never mind, it's doing its thing. Here, we'll just go back here while that's going. So what I'm trying to pull up there with the line traces and the blueprint is to show the construction graph and where range X and line spacing comes from. Because these are values that are set in the construction graph within blueprints. Um, I saw little reason to set them in C++ in the time I had because this project did start off as a senior project for the University of Mississippi I was attending at the time. So I only had like a, a month or so to realistically get all this done with everything else I had to do on top of this. I only had like a month of actual, I guess you could say, dedicated time with everything else going on. So with the actual, I think the loading of that blueprint is yeah. You know another thing I just realized? I have some Chromium-based Opera tags or Opera stuff up here, which I should probably um, close those tabs out because that probably is bogging down all of my RAM. I only have 16 gigs of it at the moment, so that's a thing to keep in mind. Anyway, it's really taking its time. I definitely need to go in and fix some of that. Anyway, going back in here, it creates it on an x-axis and then the y-axis, but where the actual function happens. So now that we have a array of line traces, which line traces are literally just lines that shoot out from a point with regards to a axis relative to itself, which you can point relative to the world. That's actually how Wind Volley works. It points these lines, which is just a bunch of invisible lines that detect like hit or collision and like hit things along that line. It uses those lines to measure like when and where it should do a force value and in what direction. And from there, it's just a case of pointing it in different directions relative to the character. So if we look at this if statement, if get world lines trace single by channel gets the hit result, transform, and everything. In other words, it gets where the actual location of the hit of each line trace is, and from there, it kind of plugs that hit result into here to see if it is testing for physics. Why is it important on whether or not it's simulating physics or not? Well, because if you're hitting a non-physics based object, because wind volley pushes back on you, you have to still apply a force, even if it's not something that's, pushable. So, for example, the ground. The ground you can't push. However, you still need to be able to push off of it. And so I still need to, even if I can't apply a force onto the ground, I still need to apply a force onto the character. And as a result, hold on, I just heard a. Okay, here it is. So yeah, there's a lot of blueprint here. This was all just prototyping. Um, this, as you can see, isn't connected to anything. This custom event isn't connected to anything. I can actually um, probably just delete that. I think I was testing something out here to. Oh, right, this was for a decoupling thing I was doing. Okay, and then casting phase. This I didn't find a reason to put destroy actor in a C++ class. There's absolutely no performance gain in doing so, at least in the current stage. But what's interesting here is the construction graph. So, as you can see, in the blueprints, we have the X, Y, Z range values, the line spacing. All of these variables are made in the C class, by the way, but they're used in blueprints as well. So in that base construction graph, that's how it allows us to. Did I accidentally X out of the viewpoint? No, I didn't. basically construct this, which this is where all the line traces kind of fill up and go again. So this is like the hitbox of Wind Volley, if you will, which the character would be here, um, facing upward relative, and everything pushes along this edge. Anyway, going back to our C++ file here, and actually if we look into the header, we can see that this is where my variables are made, my ranges, my line spacings, my max force, and opposite force, which I don't think I use opposite force. I think I opted out of using that because, like, in the calculations, I can literally just put -1 directly into the math, which, let's see if I can kind of scan for that. Essentially multiplies force. Right here, okay. Oh, I did use opposite force. Okay. Yeah, I might change this to a -1 just to avoid some, I guess, memory movement, which might, impact, not might, it will impact performance. Generally speaking, the movement of data is more expensive than the actual computation in many cases. That said, it's we set up our vectors. Well, I'm just the comments kind of say it all, to be honest. I'm a big fan of putting a lot of comments in my code, as you might see, but pretty much the if statement pushes the object back and applies an equal and opposite force to the character by just multiplying it by -1 and then applying it to the character. Else, just doesn't push it onto the thing that it's pushing against. However, it still pushes it equal and pushes what would have been an equal and opposite force. It just doesn't actually apply the force. So it still calculates what the force would be at that location. It just doesn't actually use it. And the reason for that is it's for performance reasons. Let's say you constantly click add force onto the ground, right? Because it's not a physics simulating object, Unreal Engine 5 does not like that, and it causes stuttering. I've toyed around with just using this as a universal solution to see if I could, I guess, clean up the code more, and it just stutters a lot if you point it at the ground because the ground isn't simulating physics. So Newton's Bolt is the second one, and this is the one I'm personally a little more, I guess, kind of proud of because I just found this cool little use for a logistical curve formula with regards to a video game. I don't know, it's kind of funny. So largely right now it's just the math that's in it. Some of the construction or most of like the construction and other stuff is kind of handled by the blueprints in the current iteration. Things like calling on projectile systems and like I actually think I did. Did I put the projectile system in here yet? Let me check. Okay. Anyway, this is the big thing I want to focus on here, though. So we check if it is cast, and the reason we do that is so it doesn't say have its hitbox collide with the player or anything, or let's say the player like moves and it would collide with something while they're still in the charging phase. I don't want it to like destroy, apply damage and destroy itself until after it's cast. So pretty much all we're doing here is we have the fall, which equals, like I said in the actual demonstration, the maximum height, um, which is then subtracted by the current location it is at with regards to the z-axis, which is the current height location. So what is max height? Max height is there's pretty much just a on every tick, which should be this one, right? Yep, this is the tick value, right? Okay, so Okay, no, it's down here. So, actually, there's an easy way to do this. Apologies to anybody watching the video, by the way. I haven't had a chance to look at any or work with any of my work in quite a bit of time because I had to do a lot of full-time work elsewhere and a lot of other work for just working towards a career. So I haven't actually seen this code in, I'd say, probably a good week. Anyway, so seeing that the max height is being checked on if it is lower than, or if world location is greater than max height on every tick. So this is where I was looking for. Basically, every tick, which is kind of like every frame, so to speak, um, it gets the world location, which just equals the current transform with regards to the z axis, and then checks if it is lower than 1. Why? Because that means it's below the ground. If it's below the ground, we destroy it. Because I don't want to like clog up the memory with a bunch of bolts that are just kind of infinitely falling. They may not be too expensive to have, but at the same time, it's another if statement that's being called every frame. So actually, it is kind of expensive. Anyway, every time it hits a tick, it checks if the current location is greater than the max height value. If it is, then the max height is updated to be equal to the world location with regards to the z-axis, obviously. And this guarantees that I can get a z-axis, which is the height um, measurement that is the complete and total how high did it go completely. So, like, let's say I decide, you know what, I want this thing to have the ability to bounce around, right? And a player, say, bounces it off the ground. I don't have to change much here because it's still using this and it will still get the total drop from the thing. Now, if I want to make it to where it changes depending on the arc, like, per bounce, then I'll have to modify that accordingly. But I'm not going to do something like that for a while because, and this is the kind of thing I want to get into to kind of, I guess, end off this devlog, so to speak. And that is, I'm going to be kind of stepping back from making spells for now to focus on something that's a little more important. Um, a common issue that one may notice, in fact, a good way to kind of show this is to pull up the third person blueprint. So let me go ahead and do that real quick. And basically, this issue is a longevity and performance issue, as well as a good modular system issue. It's not an issue in a sense of like, oh, everything's broken and I can't do anything with it. It's an issue in a I'm still developing a overarching system to handle all these spells because I want to make something that can handle hundreds even of spells and do so well. And to do that, I need to get better with decoupling within Unreal Engine 5. Basically, I need to modularize and kind of make it to where there's not many dependencies across assets in Unreal. So, here's what I mean. In the system, you'll see there's spell 1, modifiers. So, where's those keyword here? I'm looking for the word cast. Well, let's see. Point is, every spell is hard coded, if that makes sense. Oh, I know why it's not cast. It's because they're all variables. Yeah, so point is, nothing here is actually decoupled. These spells are hard coded to the character, and so what I'm gonna have to do is I'm going to have to focus on making that a system that is modular and decoupled, as I keep repeating like a broken record, and scalable. So the kind of plan is to get better with making the assets able to call each other without actually being hard coded or actually necessarily knowing what they're calling while knowing what they're calling, if that makes sense. This is to allow a system that, let's say, an inventory of spells, you just swap in and out, and I can slot them, so to speak, into the different spell slots of the player character. The actual input system that I'm kind of trying to work with here is that of four spells, each with four modifiers on how you can cast the spell. You put press the button for the spell to enter the charging phase. Releasing the charging phase will do the default cast. Pressing one of the modifiers will do a modified cast. It changes how it is cast depending on the modifier. This system should allow for four spells, yes, but four spells that can each be cast in five different ways. This means that you have 20 interactions that you can do in a sense at any given time with relatively few inputs in comparison. At least less than half of the inputs worth compared to the interactions. Um, 8 inputs compared to 20 interactions. And this is also kind of designed with the usability of a controller in mind. It's kind of easy to map the spells to the bumpers and triggers, and then the modifiers to the face buttons. So the only problem solving I'm doing with that is just kind of revoking the ability to jump on some spells and not on other spells because jumping is mapped to A, at least in the current build. As far as Sorcery Reborn is concerned, um, with this little devlog of just showing what I've been doing, this is kind of it as far as what I'm showing. I hope to be able to get back to I guess making another devlog probably next month with a fully working inventory and slot system and a um, long-term solution for calling spells from the player character in a way that can allow for as many spells as I want that can be scaled without impacting performance. I'm sure I know it's a lot easier um, than I'm probably making it sound, mostly because, again, it just comes down to what I said, decoupling and modularization, which Unreal Engine 5 actually has some built-in solutions for the interfaces system, which I'm probably actually going to be going for some of the more C++ driven solutions, because for something as large as the skeleton of how you call everything, I feel it would be better suited to be handled in C++ almost exclusively. That said, I might still use interfaces to just see what I can do with it, see how performant it is, and I guess just prototype with it. So, with everything kind of gone over, I wish everybody a wonderful afternoon, and I am going to go ahead and sign off.